Hello, welcome friends. Me Anila. The topic of my discussion is about buffer. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you how to solve numerical related to buffer. What is buffer? Before coming to buffer, I want to give you a brief introduction about some quantities. For example, pH. pH is the scale that determines the acidity or basicity of solution. If pH is greater than 7, it is basic solution. If pH is less than 7, it is acidic solution. If pH is 7, it is neutral solution. Similarly, pOH is also a scale that is totally reciprocal of pH. The pH of water is 7 because it is neutral. Acid has low pH, base has high pH. What is acid? Acids are proton donors, base are proton acceptors. Strong acid dissociate completely in aqueous solution. Strong base dissociate completely in aqueous solution. Weak acid dissociate partially in aqueous solution. Weak base dissociate partially in aqueous solution. Dissociation constant of weak acid is determined by Ka, dissociation constant of weak acid. Its reciprocal is Ka. Now, hydrochloric acid is a strong acid and sodium hydroxide is a strong base. Acetic acid is weak acid, ammonia is weak base. Now, what is conjugate acid and conjugate base? For example, if you have an acid, weak acid, acetic acid, it reacts with water to form conjugate base, that is acetate ion. So acetate ion is the conjugate base of acetic acid. On the other hand, ammonia, a weak base in aqueous solution, forms ammonium ion, which is the conjugate acid of ammonia. Now, I have told you about pH, pKa, pKb, strong acid, weak acid, conjugate base. Now, what is buffer? Buffer is actually a mixture of weak acid and its conjugate base. For example, if in buffer solution is that which resists changes in pH. For example, if we add strong acid to a buffer system of acetic acid and sodium acetate, strong acid releases hydrogen ions which reacts with acetate to form acetic acid. So the overall change is acetic acid. Since acetic acid is weak acid, so the pH changes slightly. On the other hand, in the same buffer acetic acid and sodium acetate, if a strong base is added, it releases OH ion that reacts with acetic acid to form acetate, a weak base. So the pH changes slightly. So that's how the buffer works. In this video, I will tell you how to solve numerical related to buffer system. Example number 1. A buffer solution contains 0.4 molar acetic acid and 0.6 molar sodium acetate. If pKa of acetic acid is 4.76, calculate the pH. Now, for the calculation of pH, pKa and these buffer, we have the equation known as Henderson-Hasselbalch equation. This equation is also for pH calculation as well as pOH calculation. There are two relationships pH is equal to pKa plus log salt upon acid, or pOH is equal to pKb plus log salt upon base. So, in this example number 1, we have concentration of acetic acid given, concentration of sodium acetate is given, pKa, negative logarithm of dissociation constant of acetic acid is 4.76. We have to calculate pH of the solution. We will apply the formula of Henderson-Hazelbalch equation. pH is equal to pKa plus log salt upon acid. Putting the values, pH is equal to, we will put the value of pKa 4.76 plus log. Since sodium acetate is conjugate base of weak acid, so it's a salt. So we will write 0.6 molar divided by 0.4 molar, that is acetic acid. After solving, pH is equal to 4.76 plus log 0.6 divided by 0.4, it becomes 1.5. Taking log of 1.5, it gives 0.176. So pH is equal to 4.76 plus 0.176 is equal to, pH is calculated to be 4.93. So we have calculated pH of solution containing a buffer of acetic acid and sodium acetate. Example number 2. A buffer solution contains 0.1 molar acetic acid and 0.1 molar sodium acetate. If pKa is 4.76, calculate the pH. So the answer lies in the question. You can see that both acetic acid and sodium acetate forming buffer are equal in concentration. When they are equal in concentration, the pKa of that solution is equal to its pH. So pH is equal to 4.76. Solution. Since acid and its salt has same concentration, so pH is equal to pKa, because we will again apply the same formula which I have applied earlier. pH is equal to 4.76 plus log salt acetic sodium acetate is 0.1 molar divided by acid is 0.1 molar. After solving, can 0.1 cancel each other, log 1 is equal to 0. So pH is calculated to be 4.76. Example number 3. A buffer has 0.5 molar acetic acid, pH is 5.06, pKa is 4.76. Calculate the concentration of sodium acetate. Now, in this is very difficult question. A buffer has 0.5 molar acetic acid. Amount of acetic acid is given, concentration is given, pH is given, pKa is given. We have to calculate concentration of sodium acetate, that is salt. Because sodium acetate is the conjugate base of acetic acid, we have to find the concentration of salt. Solution, we will apply the same formula that I have applied earlier. pH is equal to pKa plus log salt upon acid concentration. We will write down pH 5.06 is equal to pKa 4.76 plus log salt upon acid concentration is 0.5. We will write 0.5. Now 0.3 is equal to log salt over 0.5. Now we will take anti-log on both sides. Anti-log 0.3 is equal to, anti-log is cancelled by log salt concentration divided by 0.5. After taking anti-log of 0.3, it becomes 1.9, and 5 is equal to salt concentration divided by 0.5. So we will multiply zero point 0.5 by 1.995. We get 0.997 molar. That is concentration of salt. That is concentration of sodium acetate. So in this way, buffer resists change in pH because buffer consists of weak acid and its conjugate base. If a strong acid or strong base is added, pH changes slightly because strong acid addition causes the formation of acetic acid, that is weak acid, and strong base added causes the formation of weak base, acetate. So pH changes slightly. In this way, buffer resists change in pH. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.